All right, so we've seen the various problems that we might run into, right? Non-repeatable reads, dirty reads, phantom reads. So how do we fix that? So the way we're going to fix it is using these 4 different types of isolation levels, right? And each one is a more aggressive isolation level. Each one adds an additional level of locks that locks either the row, the table, the entire database, right, to allow threads to run in a particular order in a sequence, and then have all the other threads wait until that thread is done. First, we have the no isolation level at all, right, which is called read uncommitted, right, meaning everything goes, right. Everybody can read and write any way which one. Nobody's waiting on anybody, right. Now this gives you the fastest performance, right? Because everybody's reading and making the best use of CPU time, right? And it is it's the ideal for multi-threaded environments, but gives you the highest risk of inconsistency, right? That especially if you have logic that needs to assumes that things have to happen in particular order. If your logic doesn't really depend on things happening in any particular order, then this is perfect, right? That you don't have a logic that has to happen in a particular order, then this is perfectly fine. Just read uncommitted is just fine. But if your logic depends, that you need to have repeatable reads, you want to avoid phantom reads, you want to avoid dirty reads, this will not help you at all, right? You're going to have all those 3 problems with no isolation. The second, beyond that, is read committed. Now, read committed says that if there's data that hasn't yet been committed, right, we're going to enforce the fact that if anybody is going to read data that hasn't yet been committed, well, they're going to have to wait, right? They're going to be put in a queue. The thread is going to be put to sleep, and not until that data has been committed will that thread be woken up again so that they can continue. And then we have an additional layer of isolation called repeatable reads, meaning that if I want to be guaranteed that if I read a piece of information and then I read it a little bit later, a couple milliseconds later, that it's going to be the same information. Well, I can have this, right? Meaning that if I'm reading, right, and somebody comes in and is going to try and write to the information that I'm reading, right, then they're going to have to wait, right? So in the read committed, it is the readers that have to wait, whereas the repeatable read, it is the writers that are that need to wait, right? So that because I need to be able to read and make sure that I always get the same information. And finally, we have serializable. Serializable is the highest level of isolation. It means that both readers and writers are going to wait on each other. We get the locks and I don't care even if the logic would be affected, you're gonna have to wait, okay? And so these incrementally are slower performers, right? Because you are increasingly asking threads to wait on each other and causing them to waste time that you would otherwise have a better performers. Yeah, so here's pretty much what we just described, right? So the read uncommitted lowest isolation level is the fastest. We allow dirty reads are still allowed, right? Meaning that if data is uncommitted, I will still read it. Read committed, right? That I will guarantee that I'm only going to read data that has been committed, right? So I'm not going to have those kinds of inconsistencies. And then read committed isolation, meaning that I'm fixing, every time I increase these isolation levels, I am fixing a problem. For instance, here we are, non-repeatable reads and phantom reads can still occur, right? But we fix read committed, right? So here's a where is it? Here's a table that summarizes all these problems, right? Above here, at the x-axis is a list of all the different things, all the bad things that could happen, right? dirty reads, non-repeatable reads, phantom reads. So all those are the bad things that could happen, all the inconsistencies that could happen. On the left-hand side, on the y-axis here, we have the different isolation levels, right? And how aggressive are you in locking the data? And here in the table shows whether that particular isolation level fixes the problems. Notice that read uncommitted doesn't fix anything, right? We're allowing dirty reads, we're allowing non-repeatable reads, we're allowing phantom reads. So read uncommitted doesn't fix anything, right? Everything goes. Everybody can read and write whenever they want. Read committed, we're fixing the dirty read problem, right? That we're not going to allow working with stale information, right? If you're reading something, you can be guaranteed that it's data that has been committed, right? It doesn't guarantee that if you read it now and then 2 seconds later you're going to read it again, it's going to be the same information. It doesn't guarantee that, right? So in that case, non-repeatable reads are still allowed, right? And finally, we have repeatable reads, meaning that if you want to make sure that if you're reading multiple times from a database, you would guarantee that it's the same information, then you would use repeatable reads, and so we would be fixing the non-repeatable read problem. And finally, we have serializable that fixes everything, including phantom reads.